I would like to welcome everyone to our Architects Focus presentation organized by New York Passive House and AIA New York Passive House plus Modular for Affordability, presented by Paul A. Castrucci Architects, who is focused on passive house design and is involved in many large passive house buildings throughout the city. It is my pleasure to welcome today's presenters, Grayson Jordan, who is a principal at Castrucci Architects, and Ashok Tirunarukarasu, who is a project manager at Castrucci Architects. So please, Ashok, take it away.
Thank you, Andreas, and good afternoon, everyone. My name is Ashok, and I'm the sustainability lead for my firm. Grayson and I are really excited to present our firm's approach to designing low-carbon, healthy homes. We believe architecture should be equitable, sustainable, resilient, and foster community. We approach architecture holistically. We applied the Passive House methodology, and in today's presentation, we would like to discuss our approach to design by examining some of our key projects. We will look at the challenges of building affordable housing, including drivers of costs in affordable housing, while aiming to hit the Passive House standard. Finally, we will present why we have chosen to go modular on some of our projects by examining two projects, Bethany Senior Terrace and Habitat Net Zero, to further explore topics in module and passive house. Our design aligns with UN climate goals. Some 40% of carbon emission in the United States come from the building sector. New York City Local Law 97 emission caps are calculated directly from the UN climate goal, which recommends reducing carbon emission by 80% by 2050. So how well does passive house stack up here? Well, it stacks up pretty well. We use data from the city's benchmarking report as well as in-house modeling on our existing project. What we find is that existing buildings on average don't meet local law 97 for 2024, and that when we build multifamily buildings to New York City Energy Conservation Code 2016, it's just at the target for 2030. So there is a risk of not meeting the 2030 emission caps. But when we look at projects being certified to Passive House standard, we see that it comes very, very close to hitting the 2050 goals set by the city. Now, in our simulation, we didn't add renewables. So when we add the renewables, Passive House buildings would be within the 2050 standards. So now Grayson will talk a little bit more on our projects.
Yeah, thanks, Ashok. I'm Grayson Jordan. I'm one of two principals for Paul Castrucci Architect. Before we get into the modular case studies, I just want to give a little background on our firm and our historically how we've come to implement passive house in our work, and specifically how we implement it in affordable housing and how that's leading us to these explorations of modular construction for affordable housing. So the first project I'd like to look at is our first passive house project, designed in 2009. It's the ABC No Rio Community Center. It's a 10,000 square foot arts and activist community center located in Lower East Side. Our firm is a Lower East Side firm. We've been working in this community for 3 decades. And a lot of our work historically has been with local artist groups and local low-income cooperatives. Working with this group, which again is ABC No Rio, part of their design is they wanted the design to sort of visually signify their values. One of those is environmental justice. So in addition to sort of the green wall at the front facade, implementing Passive House was very much aligned with their values. ABC No Rio is a grassroots organization, and so they have not the deepest pockets. And so from our very first Passive House project, our firm has been very interested in developing, detailing, and constructible standards that can get us to Passive House on a budget. And so we're really looking to leverage existing construction materials and construction techniques that are well known by local tradespeople, and also clearly communicating to the contractors especially during the bid phase and pre-construction phase, to make sure that we're doing the best we can to deliver these ambitious energy goals within our budget. Fast forward to 2014, we've been doing, at this point, Passive House for about 5 years. We're finding that some of our clients are value aligned with us and are looking to push for sustainability, but not everybody is. And so we're looking to create a demonstration project that shows, Passive House makes sense for all projects. And so as an office, we developed a small project in Brooklyn called R951. This is a 3-family, 5,500 square foot building in Brooklyn, certified to the Passive House standard, completed in 2015. It meets and exceeds Passive House standard, and then we have supplemented with rooftop solar PV to become, I think, the first building in New York City that's certified both Passive House and NYSERDA net zero capable. And so you'll see in some of our work, this is a big interest of ours, is using Passive House to push energy use way down, supplementing with solar to achieve net zero capable buildings. And I think, again, successfully showing that Passive House can be economically implemented and can perform well on the open market. I'll turn it back to Ashok to talk a little bit about our deep energy retrofits for affordable housing.
This slide, we're presenting our benchmarked energy data for completed retrofit buildings. In our office, we benchmark all of our projects. We do this for two main reasons. One, it allows us to compare the projected energy consumption with the actual performance. And two, it also allows us to tweak our in-house modeling results. What we're presenting here are two 6-story multifamily building in the Lower East Side and a historic row house in the Sunnyside Garden District. In the larger photo, that is 544 East 13th Street. This is a pre-war multifamily building retrofitted in 2018. It has 6th floor and a basement, and it's about 14,000 square foot. And this building is an affordable co-op. So when we were retrofitting the building, because it's an affordable co-op, we had a very limited budget, but we still were able to apply the Passive House methodology. And what we find is that even when projects are not certified to Passive House, the building tends to perform really well. The good news for us is that when we compare our benchmark energy data, which is sort of shown in the graphic right above the map, so when we compare our benchmark energy data to the city's report that's based on benchmark data submitted to the city, what we find is that the performance of all 3 retrofitted buildings are in the top 5% in terms of energy efficiency when comparing to existing buildings that are the same size and have the same occupancy.
So building on that work of sort of smaller buildings and deep energy retrofits of existing affordable housing, our firm wanted to start to think about, as I think a lot of people are, addressing the larger affordable housing crisis. And we understand that this needs to be done on multiple fronts. So of course we want to continue with the deep energy retrofits. It's a really big piece of the puzzle, maybe the biggest piece. But we also want to contribute sort of on the larger new construction affordable housing. And we also recognize that some of the leaders in implementing Passive House in the city have been our colleagues designing affordable housing. So we started to seek new construction affordable housing projects that are a bit larger in scale. And so here you can see 4 larger buildings, 1 in Manhattan, 2 in the Bronx, 1 in Far Rockaway, Queens, that are beginning to get a little bigger but still implementing Passive House standards. So on the left, you'll see earlier design. Top is schematic design project in Harlem, a design development stage project in Manhattan. On the right, we're a bit further along. Bottom right is an affordable housing project in Far Rockaway, Queens, which is construction documents. And on top is a affordable senior housing building in the Bronx that is under construction now. And we're seeing between 80 units and 200 units in these buildings being between 55,000 square feet and 200,000 square feet, and housing, senior housing, general affordable housing, and supportive housing. And through these projects, we're really starting to develop a strong approach to how we approach sustainability and affordable housing.
So this slide sums up very well our holistic approach to buildings at our firm. We push for net zero energy by combining Passive House with renewables. We use energy modeling extensively in the early design phase. It enables us to make better decisions, and in most of our projects show an economic case for Passive House buildings. We also make a case to our clients to go full electrification. It helps reduce carbon emission, is cheaper on our clients' utility bill, and healthier for our occupants. And since we spend most of our times indoor, we take extreme care to use up-to-date standards to design for a healthier indoor environment by providing adequate ventilation, designing homes that will also cause fewer illnesses. We select materials carefully so they do not off-gas, and we also use therm extensively to ensure minimal condensation risk.
And so here we're seeing one of these larger passive house or medium-sized passive house buildings under construction. On the right is a 4-story, 480 unit affordable housing that's about topped out with block and plank. On the left is a window mock-up, and we're going to use mock-ups extensively throughout these projects for quality control. Affordable housing construction in New York City is really a pretty well-defined process. It's typically going to be block and plank construction. And there are a lot of people doing really good work within this typology, especially implementing passive house in New York City. But there are limitations. Specifically, there are budget limitations, primarily driven by labor cost, especially in senior housing, which, as many people may know, is driven by prevailing wage rates, which increases construction costs by up to 60 or 70%. You're also married to, for the most part, married to this construction typology. Most affordable housing is done this way. And as we begin to contemplate how do we get to true carbon neutrality, we need to start thinking about whether buildings that are primarily made of CMU and concrete plank are really the best system to get there. As with any construction typology, there are also planning and layout rules of the roads that will affect our layouts and sort of our maximum height and what we can do with our setbacks. And finally, there's always an issue of quality control, which gets exacerbated the bigger you get. So we have really a pretty robust quality control process. We're doing mock-ups, kickoff training sessions with contractors. Passive house itself requires lots of inspections and observations. We work with really good teams of sustainability consultants to help us with that. But the reality is you're not going to see every window that's installed. You're not going to see every detail that's installed. So, you know, whereas the first mock-up might be excellently installed by the best crew, do the 50th through the 100th windows get installed by the same crew? Are they done on a cold, windy day so some corners are cut? And we're always sort of looking for ways to sort of make that process better, which brings us to modular construction. Before we get into our case studies, just a word on what we mean by modular. Modular to us means it's a 3D object. We've got 4 walls, a floor, and a roof. Within that is completely finished space. So you'll have your kitchens and your bathrooms and all your finishes installed. Your windows will be installed depending on how you deliver the modular. Perhaps the facade is installed or perhaps not. These mods, as we call them, these boxes or mods, are built in the factory completely, shipped to the site, and stacked up to make the building. This is a bit in contrast with prefab panels, also a factory produced product, but this is going to be more flat pack. So floors, roof, and most predominantly wall panels built in the factory and shipped to the site and sort of tilted up. This is also a really great approach that we're looking at, especially for deep energy retrofits, sort of the energy sprung approach. And we're also actually looking at it in combination with modular. But for the purposes of today's discussion, we really are just talking about these 3-dimensional boxes or mods. And what's pushing us here? 3 main reasons. We want to control cost, especially in senior housing. The ability to push labor offsite is beneficial. We want to reduce construction time. We're expecting these projects to be delivered on site in at least 25% less construction time, probably more. And we want to increase quality control. With those benefits, there are design considerations that we have to manage. Those include the size of the mods and plans. You're going to be limited to your spans, usually much less than you would typically get, probably around 15 feet. The height of the mods, so that means both the total height that can be shipped, but also as you're stacking mods up, and you have at each condition a thicker floor plate because you have a ceiling of the mod with the floor of the mod above it, you're getting increased floor plates, which can be tough to meet the zoning requirements depending on the zoning district. We'll of course have to think about the transportation and stacking of the mods. The way that we implement MEP is going to be a bit different in modular construction, and with the more robust MEP approach a passive house. This takes another layer of consideration. And finally, we need to consider testing and inspections through a different lens for modular. So our first case study is the Bethany Senior Terraces project. This is a 58-unit senior housing building located in Brooklyn, New York. We have just finished 100% construction documents for the project, so we're close to coming to the point where we start construction. This is located in the East Flatbush neighborhood of Brooklyn. It's an R4 zoning lot, so it's fairly not very dense for New York City. A lot of 1, 2, and 3 family buildings in the surrounding neighborhood. The site itself formerly housed a sort of 3.5-story institutional use. So the sort of 3 to 4-story use we're putting back, senior housing, is actually quite closely matching it contextually. From a design perspective, we wanted to leverage, for this site, we want to leverage the advantages of the site, so that lack of density and the ability to have bigger yards, and use that to help meet needs of the residents. So with senior housing, we want to really encourage socialization in our common spaces and also encourage activity. And so that manifests itself in this project through this series of garden terraces on the south facade. Starting from the top floor where we have a community room, we're carving away that southern facade in a series of steps that sort of bring you from the top floor all the way down to the lobby. And these are garden terraces, places for the residents to sit and socialize or garden, bring you through the common space of the lobby, and then back out at the grade to this sort of generous southern garden to the south of the building, which is about 35 feet, and then terrace down to our cellar community space. And by pushing down these terraces, we create light and air into that cellar space and really create this sort of circuit of activity and socialization for the seniors. This will be a Passive House certified building. We have a great client here who sort of demands that in the first instance, and we're building on that, pushing towards net zero by driving down the energy use with Passive House and then supplementing with a really robust solar PV array on the roof. And didn't quite hit the goal, but we got about 70% net zero capability here. Here you can see a section perspective through that sort of entry lobby way. At the bottom, you see our community room opening up on grade onto the garden, which we've pushed down to that cellar level, and then sort of gradually stepping up to our lobby, and then the monumental stairs in the lobby connecting us to these terraces as we move up the building with these garden terraces to the upper community room. Here's a rendering showing that sort of terracing effect along the south facade. Okay, so looking specifically at modular, as with any design problem, we're not looking at it's not linear. We're not trying to solve one problem at a time. We're trying to solve all the problems sort of holistically and together. But one of the first things we really need to look at in modular is transportation and staging. So we need to understand the route that mods will take from the factory to the site, because there's going to be bridges and tunnels that will sort of dictate your pinch points and might change the size of your potential mods. And then at the site level, we need to look at, where on the street can we stack the mods? How many mods can we stack for one day set? And where can we put things like the cranes? And this will dictate not only construction schedule and how many mods you can set a day, but again, may also dictate the overall size of the mod and influence the building planning. So getting the ERVs into the apartments is beneficial for that. The other is there's actually some cost savings in this case, just because, and this is something that makes senior housing particularly fruitful for modular. Some of you may know that senior housing in the city is prevailing wage labor, which drives up the cost, I would say about 60 to 70% over general affordable housing. And so moving some of that labor cost to offsite is beneficial. This also affects how we're going to look at our bathrooms. So rather than back-to-back bathrooms, our bathrooms are going to sort of face the hallway. All of our stacks will be there. Looking specifically again at the ERV, you'll notice that this necessarily exhaust and intakes through the facade, which will have an aesthetic impact. Also need to carefully place your windows and your intakes and outtakes to make sure that you're keeping the clearances. Diagram. This isn't so much specific to modular, but it is specific to our goal pushing towards sort of a carbon neutral future. We want to electrify the buildings. And so we're not having gas hot water heating. We're going to use heat pump hot water heating. And so the system will be comprised of 3 tanks, 1,200-gallon tanks in the thermal envelope connected to condensers on the roof. The condensers on the roof will heat up the water. Having that amount of storage helps us sort of move the load from peak to off-peak. And then we'll have a small amount of electric reheat if we need to get back up to the proper temperature. So just wrap up this case study looking at some of the wall sections and detailing issues for passive house and modular. Excuse me, modular construction can come completely, the facade can be completely intact. In this case, we didn't go that way. Working with both the mod company and the GC, it's made more sense here to build the mods to the sheathing, dense glass sheathing, put on the air and water barrier, put in the windows, and then have the contractor come and scaffold the building and put an EIFS facade on. The thinking there is, if you imagine stacking mods up on the site, no matter what, all 4 sides of that mod are going to have to be healed. So your air barrier, your insulation plane, and your water barrier and your finish all need to be healed. And that's really important, obviously, in passive house. And so the contractor just felt that by the time they put up all the scaffold and made all these small connections, it was actually more cost effective to just do the entire EIFS facade themselves. 2 other considerations at the sort of the wall detail level. First, again, if you look at that middle part of the section, you'll see a mod has a floor and a ceiling, and then the mod above it also has a floor. And so block and plank is going to be an 8-inch block, 8-inch plank. That's your ceiling plane. This is going to be your foot for your floor plus 6 inches for the ceiling. And so you're more than double what the floor plate is for a typical block and plank. And so that's a real consideration. Does your zoning and your massing work for that? In this case, this is this particular R4 district, the setbacks were 35 and 45. And so that sort of made it work pretty well. Had it been 30 and 40, I'm not sure that modular would have worked for this site. We potentially could make it work, but it would have been harder. Also note that mods, anything above 2-family, they're going to be incombustible. So you're going to have a lot of steel. Essentially, a mod is a steel tube box. So you have steel tube columns, and you'll have W shapes that create this, in this case, 14 foot by 60 box by about 10 or 11 feet tall, and infilled with metal studs. And as we all passive house practitioners, we do know that this is not the best for thermal bridging. And so compared to our block and plank building, there's a bit more exterior insulation required to overcome that. This is just a detail at our sort of roof parapet and terrace setback. To note here, the parapets are built in the factory. Again, they're sort of like flat pack, structural steel or tubular steel rectangles infilled with metal studs and then bolted down to our mods. And that's a potentially very significant thermal bridge. And so we, at that connection, there's an Armortherm thermal break. And we're using that same detail where we're connecting our sort of solar trellis. So we want to make sure that we're planning for all these connections and thermally breaking them. Next slide, please. I'll just wrap up here before I turn back to Ashok. Pretty typical window detail for I guess metal stud and passive house. I'm showing it here to talk about the sequence of how it's going to be delivered. The mod company will build everything from the sheathing to the right. So they'll obviously do the structure. They'll do the dense glass sheathing. They'll also put the air and water barrier on. They will wrap that into the jamb, install the window, air seal and water seal to tape the window to all around, and then it'll be shipped. And the site contractor will heal all those mate line joints and install the facade. And that's it for this this part of the presentation. I'll turn it back now to Ashok to look at Habitat Net Zero.
Thank you, Grayson. The next project we're going to talk about is the NYCHA Next Generation Initiative called Habitat Net Zero. This is a project with Habitat for Humanities, NYCHA, and HPD. We're really excited about this project. The aim of this project is to develop small vacant lots to help build single-family homes. To give some context, the city has acquired many foreclosed homes and lots, and the city has been looking to develop these lots to address the acute housing crisis. Habitat Net Zero will also provide a pathway to home ownership, which is critical to addressing the affordable housing crisis and will help blunt against gentrification. So the project is located, it's on 13 sites, which are spread across Queens, New York. So a significant outcome of this project is to create a methodology to deliver beautiful homes that are healthy, energy efficient, and at a price point that is affordable. So the project scalability, especially on a citywide basis, is a critical success metrics for us. We realize that each site has a unique topography, site orientation for solar gain, lot size and lot width, and very different zoning requirements. We also have existing homes that were in various conditions, some of which were more cost effective to do rehab. So in the end, 10 of the 13 sites would be modular and 3 would be rehab projects. Based on the different conditions of the building, we saw a prototype that will deliver the healthy, affordable house that will hit net zero energy while respecting the price range. The budget also required us to absolutely go just to the essentials. So this project is nearly pass-house, but not pass-house certified. What we found was that when we go towards pass-house and add solar panels, it gives us a cost-effective net zero home. We engaged very early with the GC for site build. We looked at panel manufacturer as well as talked to modular companies across the U.S. We generally found that the more the building is built in the factory, the lower the price per square feet. Another factor that impacts the cost is transportation of the module, especially because these are smaller projects. In one instance, there was a large tree that made the transportation logistic a lot more complex, and it drove up the cost, and that helped choose that building to go for rehab. Our final hard cost is about $280 per square feet, and we are really happy with that. So here we have prototype A. We eventually came up with 4 prototypes. This is based on site orientation, lot size, zoning regulation. Many of our prototypes from A, B, B2, and C have very similar concepts. So the 10 modular homes, it was treated as one single project for DOD. And so we were required to provide one UFAS unit. So this would be our accessible unit. We tried to optimize the space. So these are some of the concepts that we applied in all of our prototypes. We really try to optimize the space to provide the maximum bedrooms allowed by code. And this really maximizes different family size and configuration. We also designed the living space in the back and opened it up to the patio, which helps extend the space and create a connection between the indoors and outdoors. Finally, we have a flex room that could be used for dining or den, but it also could be converted into a bedroom to allow for growing families and aging in place. And to help with the architectural design of the project, we added a solar parapet. We also use energy modeling extensively early in the design phase to help us optimize for site orientation, window wall ratio, and window selection. So this is like one of our studies where we were looking at the impact of where we're putting the windows, and that had a big impact on the final energy balance. Next slide, please. So here we demonstrate how the mods will come together on the site. So first, the GC scope would be the foundation. So the GC will build the foundation on site. Then the first mod will be craned in, and finally the second mod on top of that. The modular solar parapet and solar panels are then craned into place. Finally, there's the patio and the stairs, which also fall under the GC scope and built on site. So as I mentioned before, we came up with 4 final prototypes. This is type A. It's our first prototype. All of our prototypes have this living room in the rear and connection to the yard and aging in place. Prototype A is meant for lot width 26 feet to 30 feet, and the total area is 1,500 square feet. It has 4 bedrooms. This is our type B, and it's for more narrow lot. It's about 20 feet wide and about 1,000 gross square feet, and it has 3 bedrooms. This is type B2, and it's meant for larger lot size where it could accommodate 2-family homes, and where zoning allows for 2-family homes. And basically, it's 2 B units put together. Our smallest lot size home is the C. It has 2 bedrooms, and this is about 800. So now I just want to go over some of the detailing for Habitat Net Zero. We went with a wood frame construction. The cladding and exterior here, the exterior insulation here are factory installed. So if we look at the foundation, here's one of the points where we will get a thermal bridge. So how we address the thermal bridge between the foundation and the first mod is to use armored therm all around as our thermal break. Next slide, please. We use triple pane glazed window. Again, this detail is important because this is where the first and the second floor comes together, and we see the mat line detail. We also have a double floor plate here between the first and second floor. So basically, how do we get the air barrier and continuous insulation? So in the factory, about 1 foot around the mat line does not have insulation. So when the modules are on site and put together, the GC will then ensure the air barrier and the weather barrier are sealed and continuous, and then insert the insulation back. So this is the roof detail. What we see, we have about 3 inch of poly iso all around the building, except the roof has a little bit more insulation to get a higher R value. And the roof is a pretty simple construction. It was mainly driven by cost. It's a flat roof, and the insulation and air barrier is continuous and it's factory installed, so there's no problem there. There is a solar parapet that gives sort of our design feature. So to summarize, here we have 2 connections. Basically, the first floor mod to the foundation, where we have the thermal break, and then first floor to the second floor, where we have the GC that could that seal up the air barrier and weather barrier.
Great. Thanks, Ashok. I saw in the chat somebody was asking about this. So modular is going to be a little different in the approval and inspection process. And these 2 case studies are good because they demonstrate the 2 possible paths for approvals. So looking at Habitat, which Ashok just went through, smaller 1 and 2 family buildings, you apply a DOB the way that you would apply any job. They look at zoning, they look at fireproofing, but the mods themselves are considered a product. So the modular manufacturer takes the drawings of the mods, takes them to New York State, has them certified as a product, which is delivered to the site like a very expensive window, for example, or just a big sort of complex product, let's say. And sort of so the inspection of that and the certification of that is all handled offsite. For the larger projects, for most modular in New York City, again, you're applying at New York City, you're looking at zoning, you're looking at proximity to neighbors and fire protection and all those issues at the DOB level. But as you can imagine, a lot of the plumbing and sprinkler and fire protection is being built off-site. And so DOB is not sending inspectors out there to inspect that. And so the way that works is sort of a third-party inspector before approval takes responsibility for that. And these are inspectors certified by the city, by OTCR, and they will, during that process, inspect all the things that would normally be inspected on the site. So your sprinklers, your plumbing, etc. Once the mods are installed on site, there's still your normal inspections which are still in place. So you're still going to have, you're bringing in your street connections from the street that's inspected the way you normally would, and you'll have a number of special inspections, including fire stopping and whatever plumbing and sprinkler work you have on site. So that is for the approvals and state required inspections. But also when we're looking at Passive House, we have this other layer of quality control and verification. And again, that's being moved to the factory. And so that's the onus then is on the design team to set up the protocols of how those inspections go. And for both of these projects, which again are sort of wrapping up construction documents, but we have had the conversations of we really want to be doing all of our mock-ups in the earliest mods. We want to be testing the earliest mods for airtightness and making sure that all that quality control checks are front-loaded. So we, just like with any building, you want to inspect the first window to make sure that they got it right. And if there's something wrong, you fix it, and that fix can permeate throughout the rest of the construction.
A reflection we're having in our firm is reducing the life cycle carbon emission. So what we find through research is that material selection and construction of the building accounts for about 20% of the building carbon emission. And then so when we calculate it for past FUZ, this percentage can be as high as 40%. So while we see a lot of research tackling operational costs of the building, there's really little literature on carbon emission from the actual construction process. And this proportion of carbon emission during construction is significant and shouldn't be ignored. So we don't know the answer if modular construction will be effective at reducing life cycle carbon emission, but we wanted to kind of still present what we thought about it. So carbon emission from the construction process can be measured based on the transportation of materials, on-site equipment use, and on-site electricity use. In theory, quicker construction time reduces on-site equipment use and on-site electricity use. And construction in New York especially, we use significant energy to condition the site, especially in the winter. Similarly, the transportation of material can be reduced by improved logistics of manufacturer buying in bulk, and this will also help reduce material waste.
As a firm, as we're becoming more interested in understanding carbon footprints of these buildings, our next steps for both of these projects is to model them in EC3 against a base case. So for Bethany, that would be a block and tackle building. But also we're going to look at, even though it's not permitted now, we're going to look at it if it were framed primarily in wood. Just to begin to have an understanding of what the ramifications of those design decisions are, and maybe move the conversation to a point where like more of a wood frame building might have really positive carbon aspects, and just trying to figure out how do we make those buildings safely, but also deliver sort of on a carbon neutral future.
So we would like to end this discussion on a few words on COVID-19. In the absence of the vaccine, the home becomes a very critical health infrastructure. And when the homes are not healthy, its inhabitants suffer. So as we move forward to a post-COVID-19 world, we need to address the structural causes of inequalities that have left millions of Americans out of the home. And the situation only grows more magnified in crowded conditions, especially in low-income multifamily buildings, where we saw higher rates of exposure to COVID-19. What ASHRAE says is that improved ventilation through filtration or dilution of the air, maintenance of water waste systems help mitigate spread of COVID-19. And we will probably see some code changes in the building to make buildings more resilient to pandemic. So some of those possible changes would include adjusting occupancy limits of spaces, enhancing building HVAC operation, improve water quality management testing and practice, requiring touchless operators and control, additional signage, and additional entrances and exits to buildings. You know, the Passive House community are trendsetters, so I think it's good to be for designers. It's good for designers to be conscious of these ways to make buildings more resilient and incorporate them in our design before the code. So thank you very much, everybody, for attending this lecture. I think we have a couple of minutes to take some questions.
There is a question regarding cost. You mentioned $280 per square foot cost. Is that hard cost, or is it hard cost and soft cost?
That's hard cost. And then for the other building, for Bethany is being negotiated. So I don't want to give the exact cost, but it is in the, I'll just give the range. What we expect to see senior housing in the city is $425 to $500. It's in that range. And what's driving the difference between those costs is really the prevailing wage. If it were general affordable housing, we expect it to be in the $250 to $300 range.
Mm-hmm. And the hard cost includes everything, kitchen and build out.
Oh yes, so the hard cost includes everything, all construction costs, and excludes obviously sort of site acquisition and professional cost.
Mm-hmm. There's a question regarding which company you used to produce your pots.
They were different on both sites. For Bethany, it's Whitley Manufacturing, which is a great company, and for Habitat, it's Modular Steel Systems.
There's one question by Caleb. He asks, which domestic hot water system did you use?
For Bethany, that was LG. We had looked at another one earlier in the process. LG was cheaper. I forget the name of the first one we looked at.
There are a couple of questions regarding what kind of cladding you would recommend.
Bethany is EFIS, which is foam, and we are looking to get away from foam. There again, you're sort of always balancing a lot of different competing requirements, and at this point for that specific project, hitting the energy requirements at the cost points is what's driving that decision. And then for Habitat, it's a range screen with corrugated metal siding and again polyiso foam insulation.
There are a couple of questions regarding which windows did you use.
I'll let for Bethany, it's being decided. So I don't want to say. We're looking at a couple of companies. They are on the higher because of the orientation, which is really long on the east and west. The windows have to be pretty good. So they're like on some of our other affordable housing projects, we're able to sometimes use not quite Passive House certified windows. But for this, these are high quality. I think it was 0.1 frames and 0.08 glass. And Ashok, if you want to take the windows for Habitat.
Sure. So for Habitat, we went with triple glazed window as well. I think the U value was 0.18. We had a couple of bidders, and we were looking at. I think Zola was one of them. I can't quite remember which one had the lowest price.
Yeah, we're looking at Zola and Yarrow, I think, for that one.
And the final question: which ERV system did you use?
Sure. We went with Zender for the ERV for Habitat.
Yep. And then for Bethany, it's Ventacity.
Very good. So I would like to thank everyone for joining this session. Sorry again for that technical problems in the beginning. We'll try to smooth it out next time. And thanks to Grayson and Ashok for the presentation. It was very interesting.
Yeah.
Okay. Thanks, guys.
Great.
Thanks, everybody. Really appreciate your time.
Thank you, everyone.